have another full day of factoring. We're just going to add on to that a teeny bit and go one step further. So let's remember how to factor. Look at example number 6 on, I believe, the front. Okay. So we know that we first have to make sure that our polynomial is in standard form and set equal to 0 before we factor. So looking at this polynomial, it is not equal to 0. We've got to first fix that. So we're going to go ahead and bring this 5 over, but we can't just float it over. We've got to use algebra. So we're going to subtract 5 from both sides. Won't that make that 0? Everybody? So we have x squared minus 2x. Now we're combining negative 10 minus 5 because those are like terms. So we have negative 15. And that's now equal to, those add up to be 0. Is everybody comfortable with that? So now we would say, remember with quadratics, we always look to see if there's a greatest common factor we can factor out first. Very, very important. But between these three terms, there's nothing in common. So it's quadratic, so we would continue to our quadratic method. Now remember, a quadratic has the form ax squared plus bx plus c equals 0. So a is in front of x squared. So our a value is 1, correct? Our b value is negative 2, and our c value is negative 15. A, b, and c. And then we go ahead and do what multiplies to be a times c. So we're setting up our little chart. What multiplies to be a times c and adds up to be b. 1 times negative 15 is negative 15, and adds up to be b, which is negative 2. So then remember, at this point, we were listing out the factors of 15, and if we don't know them right off, we're just going to list them all out. We'll do 15 divided by 1, which we know is 15 times 1. 2, does 15 divided by 2? No. 3 times 5, and then 4, no, 5. 5 times 3. And once again, remember, once we wrap back around, meaning we've already listed 5 and 3, we know we've listed all the factors. So now, 15 and 1 could never add up to be negative 2, so we cross out those factors. 3 times 5 could add up to be negative 2, but which one would need to be negative? 3 or 5, if it needs to add up to be negative 2. If we put it with 3, won't that be negative 3 plus 5, which is positive 2, guys? Yes? Which would not be what we need, right? So we have 3, and then this negative 5 would make it negative 2. 3 plus negative 5. Does everybody understand why I chose to put the negative with the 5? We would be wrong if we put it with the 3. But you've got to check it in both cases. Is positive 3 times negative 5 negative 15? Yes. If that wasn't true, if it wasn't negative 15, those wouldn't be our factors. All right, and then 3 plus negative 5 is negative 2. So now what we do is drop and break. So remember, we drop down our n terms. I'm erasing that to give myself some room. We drop down our n terms exactly as they are. So this is x squared. This is negative 15. And then remember, we're breaking. We drop and break. We're rewriting. We're breaking down the middle term. We're rewriting negative 2x. Look right here. It was negative 2. But we're dealing with negative 2x. We're rewriting it as 3x plus negative 5x. Or 3x minus 5x, right? Now, order doesn't matter. So we could either go negative 5x first and then put a 3x, or 3x negative 5x. So I'm just going to go with positive 3x. Then we're subtracting 5x. And does everybody understand how we just rewrote, is that how you say it grammatically correct? We rewrote negative 2 as positive 3x and negative 5x. Okay. So now we have 1, 2, 3, 4 terms, and we're going to factor by grouping. So we group the first 2 terms. We group the second 2 terms, always including the sign. And then we focus on this group and factor out the greatest common factor, which is x, correct? So we're factoring out an x. So we'll go back and divide each term by x. So x squared over x is x. Positive 3x divided by x is positive 3. Is everybody good? Now right here, we're going to pull out the greatest thing in common. And we're going to make sure if there's a negative in front, or even whatever that sign is, we're going to pull it out with it. So we're pulling out 5, right? Well, let's pull out negative 5. So we'll go back and divide each term by negative 5 and write what's left in our parentheses. Negative 5 divided by negative 5 is 1, so we're left with an x. Negative 15 divided by negative 5 is positive 3, so we write plus 3. Now we got to check inside our parentheses. Our safe haven is exactly the same, so we know we factored it correctly. So we're going to factor that out. We're going to pull out x plus 3. Now once we've factored it out, we can go back and divide each term by x plus 3. So in this first term, those x plus 3's divide out. We're left with an x. Those x plus 3's divide out, and we're left with minus 5. Okay, so we factored it correctly. Everybody good? How to factor? Okay. So today we're just going to use that to find the zeros. So everybody look up here. Remember back to the first day of quadratics. We have these nice U shapes with all these different features. Remember, where it crosses the x-axis are called the zeros. When we factor a quadratic, it makes it easy for us to find the zeros, and we'll talk about how in a second. So right now, it's crossing the x-axis at -1. We know we wrote that as x is equal to -1, correct? And then it's crossing at +2. X is equal to +2. So these are considered the solution. If we were to solve a quadratic, then these would be the solution. So we can solve a quadratic, find the solutions, find where it crosses the x-intercepts by graphing. Sorry, not by graphing, by factoring. So all you have to do is one step further. This is how we solve by factoring. First, make sure it's in standard form and set equal to 0, such as this. Second, factor the quadratic using our steps we just did. And then once you factor the quadratic, you'll be looking at 2 linear factors. Remember last time we talked about degree 1, correct? So we're going to have 2 linear factors. Now up here our polynomial was set equal to 0. So now we just have it in factored form. Which, guys, I want you to understand something. If I was to distribute this back in and distribute and combine like terms, we'd end up back up here. Okay? So factoring is actually just the opposite of multiplication. Anyways, so now if it was equal to 0 up here, it's still equal to 0 down here. And now what we can do is we can split them apart and write each of them equal to 0. So do you see how I wrote x plus 1 equal to 0? And then I put x minus 2 is equal to 0. And now it's one last step using algebra to get x alone. We're solving. So we would subtract 1, correct? So we get x is equal to -1. There would be a solution. We would add 2, so we get x is equal to 2. So do you see how once you factor it, all you have to do is set each of them equal to 0 and then algebraically solve. So we're almost done. Okay. So this parabola from this would cross the x-axis at -1 and 2. It would look something like that. So we could check our answers. All right, so let's go back to number 6 and let's solve it. We're not just factoring it. So we know that we've got it equal to 0. We went through this whole process and it was still equal to 0 down here. So now we're solving it. We're not just factoring it. So we're going to set each of those equal to 0. So what we're going to do is we're going to say, okay, so x plus 3 equals 0 and x minus 5 also equals 0. Now we're just going to use algebra to get x alone. So right here, what would I do? You tell me. Good, minus 3 from both sides. So guess what? One of our solutions is x is equal to -3. Right here, we would add 5 to both sides of the equation. So we get x is equal to 5. So there's our other solution. So if we were to graph the original parabola, we would see that it's crossing the x-axis at those 2 places. We've just solved it by factoring. Okay, let's do another one. Here we go. Number 4. It says solve by factoring. So our first step is make sure it's in standard form, highest degree to lowest degree, and it's set equal to 0. We're good. So now we're going to factor it. We do, okay, we're going to rename what A, B, and C is. A is 1, B is -5, and C is 6, right? So there's no greatest common factor here. So we would do what multiplies to be A times C and adds up to be B. So what multiplies to be 1 times 6, what multiplies to be a 6 and adds up to be negative 5. So then we've got to be careful and list out all the factors of 6. 1 times 6 and then 2 times 3. And this is a really good example because you'll see why in a minute. Is everybody caught up to here though so you can look so I can make some sense of something for you? Couldn't 1 and 6 potentially add up to be negative 5? Yeah, but I put the negative with the 6, correct? Now let's look at this. Is positive 1 times negative 6 positive 6? No. So even though those can add up to be negative 5, it doesn't work on this side. So we would cross those out. All right, 2 times 3. Well, we could make those add up to be negative 5, but wouldn't they both need to be negatives? Well, let's see if that works. Does negative 2 times negative 3 equal positive 6? Yes. And then negative 2 plus negative 3 equals negative 5. So we know those are our factors. So now we're to the steps where we drop and break. So we drop down our n terms exactly as they are. So we drop down x squared. We drop down positive 6. And we break down our middle term. You're rewriting negative 5x as negative 2x minus 3x. Order doesn't matter. Negative 2x minus 3x. And now we will group the first 2 terms. We'll group the second 2 terms, including the sign. The greatest thing in common here is x, correct? And then we'll go back and write what's left in our parentheses, so x minus 2. We'll factor out a negative 3. So divide each term, careful here, I'm going to write this one, negative 3. So then left is x. Positive 6 divided by negative 3 is negative 2. Our safe haven's the same. We know we factored it correctly, so we can factor out x minus 2. So then doesn't it divide out, leaving us with x minus 3. Now we know we're done almost because we have the product of 2 linear factors, degree 1, degree 1. Now look, it was equal to 0 up here, so it's still equal to 0 down here. This is just factored form of the quadratic. Now we know that we can solve the quadratic by setting each of those equal to 0. So we have x minus 2 equals 0, and we have x minus 3 equals 0. Now it's just algebra to get x alone. We'd add 2, so we get x equals 2. We'd add 3, so we get x equals 3. Does everybody understand? Those are my 2 solutions. Okay. All right, let's factor this one. Does anyone remember from yesterday, by chance, how we would rewrite this if we wanted to? I'm missing a bx, right? So can anyone remember yesterday how I rewrote it? Yeah. Yeah, well, I love it. Perfect. So I would rewrite this as x squared plus 0x's minus 25. It's equal to 0, so we can start. So there's no greatest common factor, so we do what multiplies to be a times c and adds up to be b. So a is 1, correct? Let's get a little bit more dense so we can go a little bit quicker. A is 1, c is, so this is a in front of our 1, our c is negative 25, and our b is 0. So it multiplies to be 1 times negative 25. 1 times negative 25 is negative 25 and adds up to be 0. So let's just think about it. Isn't 5 times 5 25? Aren't those the only, 1 times 25 is not going to add up to be 0. So 5 times 5, we know that those could add up to be 0, but one of them would have to be negative. Okay, well that works because it is negative 25. And then negative 5 plus 5 is 0. Is anyone lost? Drop and break. So let's finish this one off a little bit quicker. We drop down our n terms. So we drop down x squared. We drop down negative 25. And we're breaking down the middle term with those 2 things, but with x's. So minus 5x plus 5x. Group the first two terms, group the second two terms, factor out the greatest thing in common, which is x. So then left would be x minus 5. Factor out a positive 5. So then left is x minus 5. Our safe haven's the same. We know we've factored it correctly. Factor out x minus 5. So then it divided out. Once we factor it out, I'm left with x plus 5. If it was equal to 0 right here, then it's still equal to 0. It's just in factored form. But we're asked to solve. Now there is a difference, and don't make, and I've got to say this, because even in my secondary math 3 honors class, I had a lot of them miss it on the text because I said factor and they solve. So if I just said factor, we'd stop right here. If I say solve, you keep going. Does that make sense, everybody? So we're solving, right? In the instructions, solve. Okay, so now we'll set each of those equal to 0. I'm going to go over here. So we have x minus 5 equals 0, and we have x plus 5 equals 0. Solve for x. So we'd add 5, x is equal to 5. We'd minus 5, x is equal to negative 5. Are you guys ready to practice with you by yourself on your paper? Okay. So do those ones then. Check them with me. Okay, so first of all, we need to make sure it's equal to 0 and in standard form. So we'll add 12, add 12. So we have 3x squared minus 13x plus 12. And then we had hope run into where these two were switched, and that threw off the a times c thing. So if that's the case ever, where this 12 is written and then minus 13x, you'll want to rewrite it in standard form. Otherwise, your a times c will be off. So we're looking for, well, first of all, there's no greatest common factor. So we're doing what multiplies to be a times c, which is 3 times 12, which is 36, isn't it? And adds up to be negative 13, and adds up to be b. So we're looking for what multiplies to be a times c and adds up to be b. So 1 times 36, 2 times 18, 3 times 9, I think. No, 4 times 9, I think. I don't know, you tell me, calculators. 4 times 9, right? Okay, 4 times 9. And then we have 3 times 12, don't want to miss those. And I think that's all of them. 6 times 6, good. And I think then now we've got them all, right? Do we? Okay, sweet. 1 and 36 can never add up to be negative 13, or 2 and 8, 9 and 4. 9, 10, 11, 12, 13, right? But they both have to be negative to add up to be negative 13. But we're in luck because negative 4 times negative 9 is positive 36, and negative 4 plus negative 9 is negative 13. So now we drop and break, drop down our n terms exactly as we see them. That's a positive 3x squared, and then plus 12. Now I want us to think strategically here. Let's think strategically here because we can order negative 4 first or negative 9, correct? So let's think about it. If we put negative 9 first, won't that easily divide with 3? So I'm going to strategically choose to put, and either will be fine, but it'll just be easier simplification. So I'm going to write minus 9x first this time, now that we have a little bit more abilities to get strategic, and then minus 4x. Just because notice if I put the 9 first, it divides with 3, and 4 divides with 12 really nicely. But if we did it the other way, it'd be fine. So now we group the first two terms, we group the second two terms. The greatest thing in common here is 3x. Divide by 3x, divide by 3x. So then left would be x minus 3. Then in common here is a negative 4, so we'll pull out negative 4. And then left is divide by negative 4. So left is x minus 3. We know we factored it correctly. Our safe haven's the same. So we'll factor out x minus 3, and left is 3x minus 4. And now we set each of those equal to 0 and solve. So we have x minus 3 equals 0. We have 3x minus 4 equals 0. Use algebra to get x alone. So we'll add 3. X is equal to 3. And then right here, We're trying to get x alone, step by step, using algebra. When we first add 4, add 4, so we have 3x is equal to 4. One of those multiplication divisions, we divide by 3, and so we get x is equal to 4/3, which is a decimal, which we would leave it as a fraction in the most simplified fraction, which is 4/3. So we get a fractional solution, and that happens. Questions on that? Okay. Okay, go to example number 1. We're asked to solve the quadratic. So look at this. Do you see how it's already in factored form? Because we're not asked to simplify, if the instructions said simplify, we would multiply this out, correct? But this says solve. So when we solve a quadratic, the first step we do is see if it factors. And if it factors, we solve by factoring. Well, this one's already factored for us. Degree 1, degree 1. So we're almost done already. We'll just set each factor equal to 0 and solve. So we would add 3. So x is equal to 3 is a solution, minus 5. X is equal to -5. So it's kind of nice because sometimes it'll already be factored for us. If we're asked to solve, then we'll just set those factors equal to 0 and solve. Look at number 2. X times x plus 4. Isn't it already factored? Degree 1? Degree 1, correct? So we'll set each factor equal to 0 and solve. So x to the first is technically x plus 0. So let's just write x equals 0. We set that equal to 0 and set x plus 4 equal to 0. We'll set each factor equal to 0 just like before. Now solve for x in each case. So this one, we don't need to do anything. There's one of our solutions. We'd subtract 4 on this one. X is equal to -4 is a solution. So we get it's crossing at 0 and -4. Everybody good with that? So we do the same thing here. I'm not going to do another example. Okay, let's do this number 7. Here we go. Number 7 on your worksheet. It says solve by factoring. So would we on number 7 do what multiplies to be a times c and adds up to be b? What was that? Sorry? What do we always do first? Make sure it's in standard form and equal to 0. Good. So it is, right? So now, once again, we would not do what multiplies to be a times c yet. We would look to see if there's a greatest common factor, right? So isn't there something in common here? An n. Let's factor out an n then. So we're pulling out an n. So divide each term by n. So n squared over n is n. And then we have plus 7 equals 0. Now, wouldn't that be a lot easier than a times c adds up to b? Yes. So now both of them are degree 1. So we're done. But we're asked to solve. So we'll set each of them equal to 0. We set n equal to 0, and we set n plus 7 equal to 0. Solve for n. There's that. Subtract 7. So n is equal to -7, and n is equal to 0. So once again, guys, the first thing we do before we jump to a times c adds up to b is see if there's a greatest common factor. You're going to see one like that on the test, and like a lot of people miss it, but that was like the easiest one because they forget. Okay, so you're going to finish your worksheet and check it off with me. I feel like you should be able to get a lot of it done in class. We still have 30 minutes, if not all of it. You should be able to get most of it, if not all of it done. And that's yeah, we've done all the teacher examples, so we're good. Just check it off with me and I'm done.